A brief introduction to the instrument posters, if we can bring those slides up that I just gave you. All right, yeah, thank you. Oh, I guess I need this. Okay, so there are a really huge variety and a ton of exciting posters about instrumentation tonight, and I tried to break them up based on clips. There's a bunch that are already selected to fly on clips. I hopefully got them all right because I wasn't 100% sure on a couple of them. So from Cohen et al., there is the ion trap mass spectrometer for lunar volatile analysis. There are actually, I guess, two versions of this. One for clips that will monitor the near surface lunar exosphere, and then another that will go on the ESA prospect package, the Roscosmos lander, that will do the same thing, but looking at volatiles that are produced by heating drills materials. There is a poster from Koloprit et al. On the NERVIS near-infrared volatiles spectrometer system. And you've probably heard some of this already, some from this instrument already. It is sensors to identify volatiles, especially water, and characterize the environments relevant to volatile retention or form. And so this is a CLPS instrument, but it will also be part of the Viper rover. From Paul Hain, there is the Lunar Compact Infrared Imaging System. I think that is probably pronounced L-Cirrus. And that's a thermal infrared imaging radiometer that will be really highly complementary to Diviner, getting ground measurements that'll help understand the nature of the regolith and then also the nature of the Diviner measurements from orbit. Eileen Yingst has a poster on Heimdall that is 4 color CMOS cameras and a DVR that will be used for a variety of science and exploration goals, looking at the plume interactions with the surface, exploring the geology around the landing site at a meter to millimeter scale during descent, and then centimeter to sub-millimeter scale once on the surface. Bale et al. Has the Lucy lunar surface electromagnetics experiment. And this one, I didn't have to even really think too hard if it was a CLPS instrument because it is flight spare parts from like 3 different spacecraft, Parker Solar Probe, Stereo, and Van Allen probes, and a Fluxgate magnetometer from Goddard. And so this one will be a suite to measure the electric and magnetic fields, plasma waves, electrostatic signatures of dust impacts, and then radio emissions as well. So that is a really cool suite to check out. There are, I think these are the last 3 that I had, yeah. The Sun et al. Is a laser retroreflector arrays. And so these are pretty small corner cubes arrayed in a dome-shaped structure. And these are for ranging, you can range to them from orbit. So now I guess that would be from Lola. For calibrated reflectance measurements, and then these will serve as permanent fiducial markers on the surface. Nagahara et al. Has Luster, the lunar instrumentation for subsurface thermal exploration with rapidity. And that will be for measuring the heat flow of the moon. They will deploy a probe 2 to 3 meters into the regolith and then measure temperatures and thermal conductivity at different depths as it goes down. And then finally, Grimm et al. Have a lunar magnetotelluric sounder. So they will look at electrical conductivity and that will be determined through electromagnetic sounding. And this sounded like it was something that could be further developed for LGN. What's that? Oh, yes, sorry, I should have said that part. Elizabeth Frank has a poster related to a question that was asked on the anticipated challenges in payload integration on the CLPS missions. Because as she points out, usually you build the spacecraft and the payload and design those together, because changes in one has ripple effects into changes in the other. So she is looking at identifying the challenges from this new approach where they are done separately, and the potential effects that this may have, as well as solutions. I think that these were all instruments that are in development, a lot of them under Dolly or other programs, but if I have misclassified yours, please let me know. From Freemantle, there's the ultra compact imaging spectrometer for future lunar missions. And so this is a spectrometer from visible to near infrared, 600 to 3600 nanometers. Looking at everything you can do with that wavelength range, lunar volatiles, organics, minerals, and that would be from a landed platform at the centimeter to meter scale resolution. Jorge Nunez has what sounds like a very complementary kind of instrument, AMIM, the Advanced Multispectral Infrared Microimager. And that one will actually be at a much finer scale, the tens of microns kind of resolution, that will be looking to do multispectral, collect spectra and imaging at a scale where you will be seeing individual soil grains or minerals within lithic clasts. From Mazinski et al., there's a rover-mounted integrated vision system for robotic and human lunar surface missions. And this is a suite of instruments that include a science camera, multispectral imager, and then LiDAR. So you can combine these rapidly all together and use this for situational awareness on the surface. Mazilis et al. Have the remote camera and sensor system for capturing lunar lander descent and landing from the lunar surface. So I might have upgraded this a little. I think it will record a landing from the surface as it occurs. And then that will happen by ejecting pods containing imagers from the host lander at about a 50-meter height, and those will fall to the surface, make it just before 10 to 15 seconds before the lander itself, and then watch that descent as it occurs. The chemistry and dating experiment, Scott Anderson, I think, was trapped by a snowstorm in Colorado, but he's not here, so I can say that his instrument name always reminds me of like a reality TV dating show.
Hey, wait a minute.
But he wanted me to tell you that his poster will be available online as an e-poster. And that is rubidium strontium geochronology and elemental abundance for doing geochronology. He wanted to highlight the fact that they've improved the precision of the measurements by 4 to 10 times. And they can get dates that are as good as plus or minus 20 million years for a range of samples. And then Renee Weber has a seismometer for lunar network, SLN. And this is a NASA, a Dolly funded instrument that is essentially based on a COTS device that is small, it is sensitive, tilt tolerant, and broadband, so it can do a great job. a few more. This one I was not sure of its official status, but from Chi et al., there's MAG rover. So this is putting a UCLA FluxGate magnetometer onto the Astrobotic Cube rover so that you could do magnetic surveys of the surface. And then Erwan Mazarico has the two-way laser ranging from the ground station to LRO. I think that's in Spain. And so this is really more of a proof of the utility of an instrument. So they did some experiments to do two-way ranging from the Earth to retroreflectors that are on LRO. And we're able to get great results from that. And they then show that LRO flight spare or rebuilds or similar retroreflectors could support lunar laser ranging science goals. And then Cross et al. Have the in situ machine learning for lunar surface science. So they've also done some field tests deploying the system that will demonstrate in situ machine learning for lunar and planetary surface science and exploration. And this sounded like it was a way to, when you have a limited data bandwidth situation, you could have some extra autonomy from the system. This one may have fit better in the posters last night, it sounds like, with the mission concepts. But this is from Richter et al., the Lunar Surface Access Services. And this is a newly formed consortium between OHB System and the Israel Aerospace Industries that is essentially building on the Bereshit lander to provide access to the lunar surface. So you can see them for more information. Finally, there are two posters about orbital instruments. They are still important. One is actually the LAMP instrument that is flying on LRO now. So you can go see the poster from Grava et al. To look at all of the science that has come from this UV imaging spectrograph that uses starlight a lot of the time to look at permanently shadowed regions, but has done a host of measurements looking at PSRs, hydration on the day side, porosity measurements, so that's been a huge success. And then last but not least, there is, LRO is 10 years old. We should be thinking about what we will be doing next from orbit. And so I have a poster about sending ICE to the moon. ICE is the Europa imaging system that is currently in phase C being built for the Europa Clipper mission. And it can be really easily adapted for the moon. All you have to do is chuck off all that radiation shielding, and then you have a nice light camera system that would provide 50 centimeter multispectral images in a fairly wide range of wavelengths, up to 10 wavelengths through 1 micron. And then you can do native geometric stereo imaging by using 2 of those cameras so that you don't have to slew the spacecraft and you'll just be always getting stereo at the same spatial resolution as LROC currently offers from a 50-kilometer orbit. All right, and that is all for the poster session. Hopefully I haven't mangled anyone's instrumentation. And Sam is waving his arms.
We inadvertently forgot to take the photo of the Hawk and Taylor Award winners yesterday. So if you're all here in the room at the poster session, we're going to do that tonight. So all Hawk and Taylor Award winners, find me out there somewhere. Thanks.
Okay. And by the way, I know that there were a couple last minute guerrilla posters who have just skipped the abstract altogether and are putting up a poster. So who knows what those are? Go check them out.
Well, I think that's it for today's session, other than posters and networking. Pardon? There was something on ISRU, but I don't think Jerry's in the room. Is there anyone who can talk to the ISRU posters? Okay. Yeah. Where the hell is Jerry?
I can just say that we do have posters and they're out there, so come see us.
Yeah. All right, thanks, everybody.